Hi everyone, welcome to my channel. Today I'm gonna show you how to compute factorial experiment, CRD as well as randomized complete block design using the AgoR package. So I already load and submit the package to our software and to compute two-factor in randomized complete block design. I used the data that found in this package, which is referred as covercrops. So submit this one, then attach the covercrops data to your software. And if you want detailed information regarding to the covercrops, so you have to put the question mark in front of your data name. So in our case, our data name is covercrops. So type this one and submit to our studio. And there are two factors that are designated by letter A and B. A means it is different cultivar. It means three soybean cultivars. That means A1, A2, and A3. And again, the rest that means the second factor is B, which is again three types of green manure, and the level is B1, B2, and B3. Then the response variable is the yield. Then here I used this function. That means FAT, which stands for a factorial. 2 means that we are going to compute two factor, and DBC stands for randomized complete block design. So immediately in the bracket you have to put the first factor heading or column and name is A, and second factor is B, and both of factors have three levels. Then it is a symmetrical factorial experiment, and the block means it is a column that containing the response. The column that contain the replication or blocking. Sorry. Then Resp means it is the column that contain the response variable. So in our case, it is Resp. It's designated by Resp. Then mcomp means it is a multiple comparison. There are a number of multiple comparison tests, like Take is a default one, SK, Duncan also another option. So you can give all these things, but the main important things that you have to know is in order to compute factorial for RCBD is FAT to DBC are the functions, and followed by the first factor, second factor, the replication or column that contains the blocking, then the response variable. So type this and submit to our studio. Yeah, so it will give you this result. The multiple comparison test for the second factor is the result is look like this. Again, for the first factor is this. I think there is no interaction effect, so we may expect the only for the main effect of the three soybean variety as well as three green manure. So these are the graphs. This is the graphs for the second factor. That means for the green manure, and B1 and B3 levels, B1 and B2 levels are the same, but it differ from the B3 levels. Again, let's back. Yeah, this is for the first factor. That means for three different soybean varieties. Again, all are statistically and significantly differ. And then the highest yield was obtained from the A3 variety, followed by A2, and lastly by A1. So there is no interaction effect. So we are not expecting to have interaction graph. Then again, let's go for the three factor. And in order to compute the three factor in the randomized complete block design, you have to use this data, which is found in our package. So don't need to import any data. So submit this, And in order to compute three-factor in randomized complete block design, you have to use first the data name here. You have to use the function with, then again fat3dbc. In the previous, if you remember, is fat2dbc, but here is the 3. So we are indicating that to compute three-factor in randomized complete block design. So then followed by the first factor, followed by second factor, again followed by third factor, and that column that contains the replication of the block, and column that contains the response variable. So type this one and submit to RStudio. Yeah. So you can get such a result. For example, the third factor is not such highly. Again, let's see more result. Yeah, this is let's see the ANOVA, and it will give you detailed information. So you can practice in your RStudio. Then let's go to two-factor analysis for completely randomized design. And for this, I used the cloro data again, which is built in AgoR package. So submit this, and in order to compute two-factor analysis for a completely randomized design, you have to use FAT2, and instead of DBC, you have to use DIC. So you are telling to us you want to compute two-factor analysis in CRD. Then it's followed by the first factor, second factor, and the difference between the randomized complete block design and CRD is the presence of what blocking. So we will omit the column that contain the replication or the blocking. Then here is the response variable. So in our case, maybe screen here, planted, whatever it is. Then you can also give this result into the bar plot. So that means designating of what the y-axis, and again is addmean removing of addmean equals to false is removing of mean value, and also you can give the legend. Yeah. So if the interaction effect is significant, we are only displayed the interaction effect and discard the main effects graph. So these are the first factor, that means IN, and second factor, the second factor, which stands for NI, and the other factor with 4 level. Here is the stage. This is Planto, R1 plus 50, V1 plus 50, and V3 plus 50 are the second factor, and there it is levels. So by this way, R will give you for two-way analysis for CRD design. If the interaction is significant, so don't expect the main effect of the two factors. Lastly, let's see about the three factor in completely randomized design. I use the same data, but I change it into 3 factor. In order to do that, you have to use FAT3, then DIC. That helps us to compute factor analysis in completely randomized design. So it is followed by the first factor, followed by the second factor, third factor, then the response variable that you have. So type this and submit to RStudio. Yeah, I forget to include one bracket in case. Yeah. So it will give you this all results. So this is all about today's tutorial regarding to factor analysis in completely randomized design and randomized complete block design. Thank you for watching. Have a nice time.